Okay, in this video we're going to talk about alpha decay and how to solve for the products of an alpha decay. So first off, alpha decay is a nuclear reaction where the nucleus, so the center of the atom containing the neutrons and protons, releases an alpha particle. Now, so alpha decay releases alpha particles. That makes sense. Alpha particles are helium nuclei. So what that means, if we take a look at the periodic table, helium has an atomic number of 2. It has an atomic weight of 4. So an alpha particle, if we're going to write it out shorthand, would be like this, where we've got the atomic number and the atomic mass for that particle. Now, of the 3 types of particles that radiation will emit, alpha particles are the heaviest. They've got an atomic mass of 4, which is pretty large. So what that means is these do not penetrate matter well. When we talk about alpha particles can easily be blocked by a sheet of paper. So of the 3 types of radioactive particles, these are the easiest to stop. These also have a positive charge of +2. They have a +2 charge because it's just the helium nucleus. Helium has 2 protons, so each proton's worth +1. It's going to be a +2 charge. Now, when we have alpha decay, the example sort of problem would be given a radioisotope. So americium-241 would be the radioisotope. To figure out what that would look like in a nuclear reaction equation, americium is going to be Am. Now, we know that by looking at our handy-dandy periodic table. So, americium is right here. So, we've got americium-241. So, we're going to put 241 up here. The atomic number is 95, so we'd put a 95 down here. So this is then going to decay. We want to find the decay products. So if it emits an alpha particle, we already said what an alpha particle is. It's a helium nucleus. And it's always going to be an atomic mass of 4 and an atomic number of 2. Now, with chemical reactions, we always had the same type of element going in as a reactant as coming out. With nuclear reactions, that's not the case. So americium is transforming into, well, part of it's flying off as helium, and the other product is going to have 93, because it has to add up to be the same number. Atomic mass-wise, we started out with 241, and we've got 4, so it would be 241 minus 4, this would be 237. Okay? To figure out what that would end up being, well, we go down 2 on the periodic table. So we were here at americium, we're going to end up here, 2 to the left, or an atomic number down 2, and that's going to be neptunium. So neptunium is Np. So our products then would be 237 Np. Okay? Now, interestingly, 237 Np, neptunium, itself will undergo alpha decay and end up being, 237 would go down to 233, and neptunium would change into protactinium, and then so on and so forth until finally it comes down less than lead and you get a stable isotope. So that's the decay chain. These things will keep decaying until they have an atomic number of 82 or less. Okay, so that is alpha decay. Every time we do alpha decay, we're going to take whatever the atomic mass is, subtract 4, and that would be the product. Whatever the atomic number is, and subtract 2, and then that's how you find the product.